All right, let's just jump right in. What if I told you there's a new way to build AI that could change absolutely everything? I'm talking about an architecture that isn't just a little bit better, but one that's way smaller, way faster, and almost unbelievably energy efficient. Today, we're going to break down a paper about something called Bitnet. And folks, this might just be the beginning of a one-bit revolution for AI.
And, this quote from Bill Gates, it really just nails the core idea here. Our own brains, for all their incredible complexity, are basically running on simple on or off signals. So the question becomes, what if we could build AI that works the same way? What if we could just ditch all the complicated math and get back to simple binary logic? That's the big idea that Bitnet's trying to answer.
But first, why do we even need a revolution in the first place? Well, it's because AI has a problem. A massive, growing, energy-guzzling problem. These large language models we're all using and hearing about are amazing, but they come at a really, really steep price.
For a while now, the thinking has basically been bigger is better. You get models like GPT-4 with billions or even trillions of parameters. But this constant growth has pushed us into a real energy crisis. To run these things, you need gigantic data centers that are just chugging electricity, which makes them incredibly expensive and, honestly, pretty concerning for the environment.
Okay, so this is where it gets real. The research paper shows that just a single, tiny operation inside a 30 billion parameter model can use over 56 joules of energy. Now, that might not sound like much, but an AI model does trillions of these operations. It adds up incredibly fast and just shows you how unsustainable the path we're on really is.
So this is the critical question the whole field is facing right now. We can't just keep making these models bigger and hungrier forever. It's just not going to work long term. There has to be a smarter way to do this, a way to get all that power without the crushing energy bill.
And that leads us to the main strategy people have been using to try and fix this. It's a process called quantization. And the whole idea is pretty simple. Make the AI models smaller and more efficient. And there are basically two ways you can go about this. The first one, post-training quantization, is kind of like taking a fully baked cake and then trying to carve it into a smaller shape. Yeah, it's easier to do, but you end up losing a lot of the good stuff. In AI terms, that's accuracy. The second approach, quantization-aware training, is like designing a recipe for a smaller cake from the very beginning. It's definitely harder, but you get a much, much better result. And that second path is exactly where Bitnet lives.
So Bitnet takes this idea of baking it in from the start and just pushes it to the absolute limit. We're not talking about making the model a little bit smaller here. We're talking about rebuilding it from the ground up on a completely different, radically simple principle.
So here's the magic trick. Normally, a model's parameters, its weights, are these really complex, high-precision numbers. But in Bitnet, they are ridiculously simple. Each weight can only be one of three values, +1, -1, or 0. That's it. Think of it like a giant network of simple light switches that can be on, off, or inverted. It's the most extreme version of shrinking a model you can possibly imagine.
And this diagram shows you exactly how they pull it off. The overall design is still a transformer that's the same architecture behind things like GPT, but they've swapped out the core engine, the part that does all the heavy, expensive math, with this new, incredibly efficient bit linear block. What this really means is that most of the math inside the model suddenly becomes simple addition and subtraction instead of costly multiplication. It's a huge change. Okay, this all sounds great on paper, right? Simpler, faster, way more efficient. But the billion-dollar question is always, does it actually work? Can an AI built on these simple little switches really compete with the massive, complex models we have today?
And the answer, it turns out, is a huge, resounding yes. The research shows that Bitnet, even with its super simple 1-bit weights, performs right up there with standard 16-bit models. That's just wild. It learns almost as well, which is a result that kind of defies everything we thought we knew about needing high precision for good performance.
And this is where it just gets mind-blowing. I mean, just look at this chart. A standard 16-bit transformer is that big bar on the left, using over 5 joules. Bitnet, on the right, you can barely even see its bar. The difference isn't just big, it's staggering.
To put a number on it, for a big 30 billion parameter model, Bitnet is nearly 30 times more energy efficient. Let me say that again, 30 times. We're not talking about a small incremental improvement here. This is a massive leap forward. It's a complete paradigm shift.
And honestly, this might be the most important discovery of all. Bitnet scales. See, one of the biggest breakthroughs in modern AI was finding these scaling laws. Basically, a predictable rule that says if you make a model bigger and feed it more data, it gets smarter. Well, Bitnet follows the exact same rules. That means we can keep making it bigger and better, just like current AI, but we get to keep all of its incredible efficiency. It's the best of both worlds.
So let's recap. We have a 1-bit model that performs like a 16-bit one, is vastly more energy efficient, and we can scale it up predictably. So what? What does this actually mean for the future of AI? And for us?
Well, the implications are just huge. I mean, imagine having AI that's as powerful as the stuff in the cloud today, running directly on your phone, no internet needed. For anyone building AI, the cost to develop and run these models could just plummet, opening the doors for so many more people. We're also talking about a massive reduction in the environmental footprint of data centers. And this could kickstart a whole new generation of computer chips built specifically for this kind of hyper-efficient AI.
You know, this research really forces us to ask a big question. For years, the path has been bigger, more complicated, and more expensive. Bitnet suggests there might be a totally different path forward, one that's smarter, leaner, and, in the end, way more sustainable. So is this the end of giant, power-hungry AI? Maybe not the end, but it sure feels like the beginning of a whole new chapter.